Okay, so Unit 5.6 notes, factoring polynomials with special cases. First, they give you a factoring flow chart. So kind of like the steps you would go through depending on how many terms you have. This is the same flow chart as on 5.5 notes. Okay, so if you have 3 terms, you factor using the AC method. If you have 4 terms, you factor by grouping. But now, if you have 2 terms, so right here I'm going to highlight this. If you have 2 terms, you're looking at your exponents. If it's even, you're going to do difference of squares. If it's a 3, which means it's a cubic, you're going to do sum or difference of cubes. So we already talked about the 3 terms, 4 terms. Now we're looking specifically at the 2 terms. Okay? Remember, if you get to the end, the last step, and you can still factor, what do you have to do? Continue factoring, because if it's not simplified, then you don't get the correct answer. So looking at the first part, make sure you have your notes out and you're writing it down. Okay. Difference of squares. So difference of squares is when we have 2 perfect squares that are subtracted from each other. It can be factored into the following form. So think of this like your formula here. A squared minus B squared is equal to A plus B times A minus B, where A and B are the constants in front of the variables. Okay. Guys, this is going to be on the test. You guys need to focus, pay attention. This is on the test. Okay, so if we're looking at number 1, let's first label our A and B. What is going to be A?
4.
Just the constant. 4, so just the coefficient 4. And then our B is going to be -9. So don't think of A, B, and C from quadratics. We're looking at this formula up here where it says A squared minus B squared. And here we have 4x squared minus 9. Okay? So in order to find our A and B, we have to take the square root of these numbers. And I should not have wrote that negative right there, just that. So what's the square root of 4? 2. And what's the square root of 9? 3. So that means we have our A and B value to be 2 and 3. And then remember in our formula, we had A squared minus B squared is equal to A plus B times A minus B. So since we have 2 and 3, that means our factors for this is going to be 2x plus 3, 2x minus 3, and that is our answer. Okay, and here we're just factoring them. Okay, again, this is a special case. This is not going to work for every single factoring one, just if we have something that looks like the A squared minus B squared. Okay. So example 2. Okay, first let's label A and B. What is A? 81. What is B? 25. Now we're going to do what to each of those numbers? Take the square root. What's the square root of 81? 9. What's the square root of 25? 5. But notice here, what is different about this? Is this x squared?
No.
Good. The last one was x squared. This is x to the 4th. So instead of each of them just getting 1x, each of them are going to get how many x's? 2. So we could write this as 9x squared minus 5 times 9x squared plus 5. That's our answer. Say that again. Yeah, but you can't square root the 5. That's correct. So if you did this and the B value was also able to take the square root, then yes, you could simplify further.
I could do minus 5 first.
It doesn't matter. You can do minus or plus first. Doesn't matter. Okay, look at this one. Can we take out a GCF first? Good, a 2 and what else? An x. So if I take out a 2x, I'm left with 36x to the 6 minus 1, right? I took out 2x from 2x. Where did I get the 6? I took out an x from x to the 7th, and it dropped down to x to the 6. Okay. Now look at our x. What is inside the parentheses? X to the 6 power. So if we were to split this into 2 factors, each one is going to get how many x's? 3. But first we have to take our square roots of our a and b values. So a is what number? 36, and b is 1. What's the square root of 36? 6. What's the square root of 1? 1. So what would our 2 factors look like? You're going to carry the GCF with it. So
the sign, like the negative sign with the 1. Would it be negative 1 square root or just like
no, you only take the number, not the sign with it. So you would bring the 2x down, and then we would have what? 6x cubed minus 1 times 6x cubed plus 1. That's my answer.
oh wow. Very easy. Does it get harder? I'm just
Well, for a difference of squares, no, that's as hard as it gets. Now we're going to do sum and difference of cubes.
oh my god, the notes are so short.
Yeah, it's short, very short.
All the notes would be like this.
Okay, any questions on difference of squares? Remember, this is going to be tested. There's a whole lot of talking and not a lot of writing.
Why is it
Why is it x cubed?
Because you times the x
Because we had x to the 6 in the middle here. And in order for us to split it between 2 factors, they have to get the same amount. So we divide it by 2. We did the same thing to x to the 4th. We gave each one x squared. Okay, now we're going to be doing sum and difference of cubes. So 2 perfect cubes that are added or subtracted from each other can be factored in the following form. Okay, so notice here we don't just have one formula, we have how many? 2. So we have when a cubed is minus b cubed, and we have when a cubed is adding to b cubed. Okay, notice the signs are going to change a little bit depending on what it is. Okay, so looking at example 4, are we going to use the first formula or the second one? Second one. I'm going to go ahead and write it here so I have it. So this is going to be a plus b, a squared minus ab plus b squared. Okay, so we still have to find a and b. But now, instead of taking the square root, we're going to be taking the cubed root. Yes, question?
Well, we have to memorize the formulas.
No, I'll give them to you.
Okay.
Okay, so first, let's label our A and B. What is A? 27. What is B? 8. Now we have to take the cube root. What's the cube root of 27?
Good question.
So think of it this way. What number times itself 3 times is going to give us 27? Not 9. 9 times 9 is 81.
Oh, so that's
3. 3 times 3 times 3 is 27. So the answer is 3.
what number times 3 times?
Yeah.
Well, like what number times itself 3 times? My bad. Okay. So what about the cube root of 8? 2.
I memorized this.
Okay. So for this one, we're going to do A plus B. Okay, so this is going to be 3t plus 2. Can't forget about that variable. Okay. Then we do a squared. So what's 3 squared?
Nine.
9, so we have 9t squared. Then it says minus ab. So what's a times b? 6. So this is going to be negative 6t. And then plus b squared. So plus,
Wait, why are we squaring the a if we're gonna put a squared again next to it? Couldn't you just put 3t squared because you're gonna square it again later?
what do you mean 3t
Because
squared?
for the 9t squared, you squared the 3 and then added the t squared.
Okay, so don't, for this one, we're ignoring the variables in this case. So for the variables on this one, you're always going to have in that second parenthesis something that looks like a quadratic.
That's not what she's saying, though.
Okay, then,
She's asking why you squared it if you're going to square it again.
Because you did 3 to get the 9t squared. You did 3 squared,
yes,
which gave you a 9. But
Yes.
then why are you putting the t squared next to it
If
again?
you already squared it.
okay, but t squared and doing 3 squared are two separate things.
So the square applies to the t, not the whole thing.
Okay.
Correct,
Okay.
correct. Okay,
Okay, so what about 4 then?
with that plus 4,
Yes.
because it's b squared. What is b?
Couldn't you just put 2 squared?
You could put 2 squared, but 2 squared can reduce to 4. That's why we put 4. Okay? Okay, good. That's my answer. Okay, good questions here. We got 3 more. Okay, example 5. Are we using the first formula or the second one? First formula or the second one? First one, so we have a minus b times a squared plus ab plus b squared. Make sure we're writing down the notes, guys. Okay. But before we try to find these cube roots, can we take out a GCF?
Yeah.
Yes, what is our GCF?
2 and 2 cubed.
Correct, 2n cubes, which means we're left with
3.
what's 54 divided by 2? 27n cubed minus 1. Okay, notice before we do the sum and difference of the cubes, we need to get that variable cubed. Okay, so we had to take out a GCF before we got that 27n cubed as our first term. So looking at just the parentheses, what is our a value? 27, and what is our b value? 1. And what do we do to each of those numbers? The cube roots. What's the cube root of 27? 3. What's the cube root of 1? 1. Okay, so then we use our formula. So I'm going to bring down my GCF of 2n cubed. Okay, and then I have a minus b. So I'm going to have 3, what? 3, not just 3 minus 1. Don't forget about a variable. 3n minus 1. Okay, then I'm going to have a squared. What's a squared? 3 squared, which is 9. And then I'm going to have n, what did I do on the last one? Squared plus ab. So what's a times b? 3. So plus 3n. Then plus b squared. What's b squared? Just 1. That's my answer. Yes, question.
How do you know because for the first part, you said that A is, how do you know if, there's going to be a variable?
So how do I know there's going to be a variable? So the setup right here, how we first write just one of the variables, it's always going to be like that. Then we write the n squared n. The only time this is going to be different is if we have a higher variable, then this would be n to the 4th n squared. Okay, we're going to see that on some other examples. In real life, every single day. Every single day. Once you have kids and have to help them with their Algebra 2 homework.
What if I just don't want help?
There you go, pay for a tutor. Okay, for this one, can we take out a GCF?
Yes.
What can we take out? For sure, t squared. Okay, that is a great question. Can we do 125 divided by 8? No, we can just take out a t squared. By 2, 125 divided by 2? Nope, can't do a point. Can't have a decimal. So, nope, can't take out anything but a t squared. When we take out a t squared, we're left with 64t cubed minus 125. Okay, so what's our a value? 64. And what is our b value? 125. What do we do to each one? Take the cube root. What's the cube root of 64? 4. What's the cube root of 125? 5. Because 5 times 5 is 25. 25 times 5 is 125. Okay? So again, are we going to be using the first formula or the second one? The first one. So I have a minus b and a squared plus ab plus b squared. Good. 4t minus 5. So I'm bringing down my t squared. And then I have 4t minus 5. And then what? Good. 16t squared plus, what's next? 20t plus 25. That's my answer. Okay, we got one more. One more, and then you guys can work on the practice. Okay, for this one, can we take out a GCF? What can we take out? Can we take out anything larger than a 2? That's the question. Sorry?
6.
Zooming out, yeah.
No. It's just 2.
Just 2, that's correct. We can only take out a 2. I was just making you think, right? I'm not going to be there when you're taking the test being like, are you sure it's 2? Did you check other ones? No.
Yeah, I'd rather you not be here than say something like that.
That would be so much pressure. Okay, so if I take out a 2, I'm left with what? 27t to the 6th power plus, 64. Okay, what do we notice about this?
You can't do anything because it's a t squared.
Okay, so we could still do something, right? T to the 6th power, is 6 a multiple of 3? Yes, that means we can still use the law of cubics. But that means when we're writing our answer, we're not going to just start off with t squared, t, like we were doing in the other ones. We're going to have one more t added to it. But first, we need to do our a and b. So what's a? 27. What's b?
64.
What's the cube root of each of them? 3 and 4. And which formula are we using? The second one. So I have a plus b times a squared minus ab plus b squared. Okay, so a plus b, that's going to be 3. We're going to use one more variable than before. So instead of 3t, it's going to be 3t
Squared.
squared. So 3t squared, and I can't forget to bring down that GCF. Okay, plus 4, because that's my b value. Then I have to do a squared. What's a squared?
9.
9. But instead of doing 9t squared, we're going to do 9t to the 4th.
4.
Okay, remember we want our t's to be either t squared t or t to the 4th t squared. Okay, so this is t to the 4th minus ab. What's a times b? 12 t squared plus 4 squared, which is 16. That's our answer. Any questions?